Good morning. My name is Veselvam, Assistant Professor, Mechanical Engineering. I discuss about the advanced IC engines. The Unit 3 Emission Formation and Controls. The following topics are discussed. First one, formation of NOx, nitrogen oxide, hydrocarbon, carbon monoxide mechanism, smoke and particulate emissions, greenhouse effect, method of controlling emissions, three-way catalytic converter, particulate trap emissions and measuring equipment, smoke and particulate measurement emission norms, national and international emission standards. First one, the formation of nitrogen oxide mechanisms. Oxygen and nitrogen molecules are formed due to the peak combustion temperature and persist during expansion and exhaust in non-equilibrium amount within the combustion chambers. The concentration of NOx will fall with the pressure and temperature during expansion stroke to negligible level at the equilibrium condition during the exhaust valve openings. Concentrations of NOx in exhaust gas well above equilibrium values. Then nitric oxide is the major sources of pollution in industries. Here NOx is produced in various ways like thermal, fuel and prampet. Thermal NOx, due to the heat generation, large amount of thermal NOx is produced. When natural gas undergoes combustion process, but the coal fuel it contains nitrogen. When the combustion takes place in coal, minimum amount of NOx is produced. Thermal NOx occurs when the temperature is in the process of more than 1600 degrees centigrade. This is due to the dissociation of nitrogen and oxygen molecules. Fuel NOx. Fuel NOx is produced when the fuel which contains nitrogen undergoes high combustion temperatures. For example, coal fuel or oil fuel undergoes this type of NOx formation. During combustion, the nitrogen bond in the fuel is released as a free radical and forms free nitrogen and nitrogen oxides. The combustion stage in the volatile nitrogen is first oxidized, then react with the intermediate and nitric oxide is formed. Then third one, promote. The reaction of nitrogen with the atmosphere gives out promote NOx. This is then react with the carbon, hydrocarbon and hydrocarbon which is delivered from fuel. This type of NOx occur in the early stage of the combustion process. This type of NOx formed when the oxygenated fuel such as the biodiesel is combusted under low temperatures. The formation of NOx concentration in the exhaust gas from the SI engine is reduced by decreasing the oxygen available by decreasing the air fuel ratio and homogeneity of the mixer, decrease in the combustion temperature, increasing valve overlap by adding exhaust gas to the fresh sources, avoiding knocking combustions, reducing the spark timing, decrease the compression ratio, charge temperature, speed and mixer pressure. The next one, formation of carbon monoxide mechanism. Carbon monoxide is emitted with the exhaust gas due to the incomplete combustion of carbon. This incomplete combustion occurs due to this dissociation process. The measured concentration of CO is greater than the equilibrium concentrations. CO concentrations does not drop to zero when the mixer is chemically correct and linear. Formation of hydrocarbon mechanism. Hydrocarbon level in the exhaust gas is in the range of 1000 to 3000 ppm. Hydrocarbon emission rises rapidly as the mixer becomes substantially richer than the stoichiometrics. The land mixer hydrocarbon emission can rise rapidly due incomplete combustion or misfire in the fraction of the engine operating cycles. Hydrocarbon emission formation mechanism are dealt as follows: leaving a layer of unburned air fuel mixture to adjoint ball is known as the flame quenching. Crevice volume plays a vital role in the hydrocarbon emissions. The next one, smoke emissions. Carbon particles suspended in the exhaust gas is known as the smoke. It is generated when the engine is accelerated or dilated. The smoke color determines in the problem of the engine. Different color of smoke are produced while using the diesel engines. White smoke will arise when the fuel is not fully burned or due to the cold engine or leakage in the coolant. Black smoke is caused due to extremely rich air fuel mixture. White smoke is caused due to the cool engine or cool leakage. The next is smoke formation mechanisms. Fuel trumpet is made up of several layers. After ignition, the process first starts at the outer layer of the fuel trumpet. As soon as outer trumpet of the ignition heat is generated, it passes to core of the fuel trumpet. At the core, the oxygen contains little or no oxygens. The hydrocarbon get cracked into hydrogens and carbons. Hydrogen has more affinity towards oxygen when compared with the carbon. The factor influencing smoke productions: engine details, fuel factors, engine maintenance. First, engine details. Engine details, the first one, engine design. Design: quantity of fuel introduced, mixing ratio of the fuel, heat due to uncontrollable combustion process. The inlet port designs: movement of air, time intensity of premixing and burning chute, heat loss on the walls. The fuel factors: ignition delay and fuel mixing completely depends on the cetane number. Ignition of fuel depends on the fuel injection quality. Fuel should be ignited slowly. Viscosity of fuel affects the penetration of the heat to its core. Engine maintenance: injection systems, block at the nozzle holes should be reduced. Checking the piston rings, cylinder chambers, plungers, fuel injector needle, fuel filters, etc. Loss of compression due to worn out piston rings, seating walls, fuel intake system, etc. Particulate emissions: small solid particle and liquid droplets are correctly termed as the particulates. These are present in the atmospheric fairly large numbers and sometimes poses a serious air pollution. The size of the particulate is major factor. Particulate range in the diameter of 0.0002 mm with a lifetime varies for a few seconds to several months. Its lifetime depends on the settling rate, size, density, and turbulence of air. Sources of particulates: natural sources, man made factors. The next one, greenhouse effect. Carbon dioxide, although a relatively insufficient non pollutant species in the atmosphere, is of serious environmental concurrence. Among the constitution of the atmosphere, only carbon dioxide and water vapor strongly absorb infrared radiation and effectively block a large fraction of the earth emitted radiations. The radiation thus absorbed by CO2 and H2O vapor is partly remitted to the earth's surface. The net result is that the earth's surface gets heated up by phenomena called greenhouse effect. The emission control systems. The fuel system optimizations, control of ignition timing, exhaust gas recirculation, engine design modification, exhaust gas after treatment using catalysts, fuel modifications. The fuel system may be optimized by using the electronic fuel injections, equal distribution of mixer to all the cylinders, automation of fuel for better mixing, avoiding variance in the idling speed. Then exhaust gas recirculation system, that is the EGR system. In this method, the little amount of exhaust gas is sent into the engine cylinder. This reduces the combustion temperature and thereby prevent the NOx pollutions. Evaporative emission control system. Evaporative emission control system is achieved by absorptions. Positive crankcase ventilation system keeps the engine crankcase fumes out of atmosphere. Catalytic converter, thermal reactor for burning and chemically changing the harmful exhaust by produced into harmless substance. These harmful toxic substance in the SI engine exhaust gas are mostly made harmless by means of catalytic converters. The catalytic converter is installed between the exhaust manifold and muffler in the exhaust system. Thank you.